Yeah, so hello and welcome to STEMbridge. This is my first video. I was actually inspired to start creating these videos because I had the opportunity to meet some kids while at home on my vacations, and then I realized that the mathematics is not being taught as it's supposed to be. I don't know whether they're not understanding it or they forget it once they go home. As a person who used to face a lot of problems with mathematics, largely because maybe it was from my end, I didn't like it. And then the other one being, I don't think I used to practice enough. I know how frustrating that is, and especially when your friends are clocking those higher ups, the 90s and stuff, and then you're not, So, I think I decided to make these videos to bridge that gap, and I hope I get to make many more. So you can subscribe and follow, turn on the notifications. Yeah, so the first topic I decided to teach is indices because it's like very basic, and then it opens way for us to talk about things like standard notation, scientific notation and all that. So let's get started. Yeah, this Cambridge. So what are indices? So indices or powers show how many times a number is multiplied by itself. So like from the example down here, 2 by 2 by 2 means 2 to the power 3, right? So the two here, the bigger number, is called the base, you see. Yeah, and then the 3, which is the index, the smaller number, is called the index or power or exponent, right? So if you want to read it, you read it as 2 raised to the power or the power of 3, or you read it as what? 2 exponent 3, right? So why this notation? Why do we come up with this? Sometimes as scientists you have to express quantities in this form. You can't be writing 10 by 10 by 10 by 10 as we are supposed to say 10 million. You see, it's very cumbersome to write all that million figure, so we just decide to use this, and then yeah, so that's why these things came up. So there are some basic laws that govern, indices, and in mathematics, as all sciences, everything has to do with laws, theorems, and what's not. So there are some 6 laws I'll be talking about here. So let's start. Let's get in. So the first law says when two same bases, right, are multiplying. When two same bases are multiplying, you add their index. So look at here. When multiplying indices with the same base, right? So when multiplying indices with the same base, add the powers. So look at this. When two same bases are multiplying, you add their index, right? So you have let's take another example. So a to the power let's take another example. So you have something like b to the power x, right, multiplying b to the power y. What do you have? B, then you add x plus y, so that's x. Yeah, understand? So let's put numbers instead of the alphabet and let's see how it goes. So for example, you have something like 3 raised to the power 2. We said same base, so it should also be 3, then raised to the power, let's say 4. When you do that, what do you get? You get 3 raised to the power 2 plus 4. And what do you get from this? 3 raised to the power 6. Yeah, so that's how it goes. So let's see this example. So let's take this example. My first example here is a to the power 4 by a to the power 3. So what do? You see the bases are the same. That's what you realize. So you write one of them down, then you write your 4 plus 3. So that gives us what? A to the power 7, right? Good. So if you have something like this, let's say 2a to the power 3 times a to the power, or times, let's say times a to the power 4, right? What do we have here? So 2a cubed times a to the power 4. You know that there's a 1 here, right? Every number written, every unit written as its own without a preceding number has a 1. So this simply means 2, and you know there's also a multiplication, right? Times 1 times a to the power 4. Now there's a property called the commutative property, right? So the commutative property, it's works on addition and multiplication. What it means is that if you have something like a plus b, you can write it as b plus a, and if you have something like a plus b plus c, you can write it as what? A plus c plus b, or b plus c plus a, or what. Wherever you change, no matter how you change the positions, like nothing changes about the result. Same thing with multiplication. AB can be written as BA, ABC can be written as what? ACB, BCA, BAC, CAB, etc. Good. So with this, because of that property, that's why you can group all numbers somewhere, or all items somewhere when it comes to this addition and multiplication, right? So the numbers, group them at one place because it won't affect the result. Then you have your a cubed and your a to the power 4 also at one place. So 2 times 1 gives us the result of 2. And then from the first law, when two same bases are multiplying, you add their index. You understand? So what do you have here? 2 times a to the power 7, which can be written as 2a to the power 7. I hope everyone gets it to this point. Okay, so the next example I'm going to give, going to look a bit complex, but it's not. Sorry for that. So the next example is this: for let me take it again. 4a, right, cubed multiplying 7a squared. So if you've understood what I've said, you can just pause it, then solve it on your own, then later compare the answer to what I have. So this is what? 4 times a cubed times 7 times a squared. Grouping your numbers somewhere in the alphabet also somewhere, you have 4 by 7 by a cubed by a squared. So it means you have what? 28 by a same base. So you add their index. They are multiplied, so you add their index. So you get what? 28 a to the power 5. Right? Yeah. So that's it. Should I give you another example? I don't know how to wipe this thing off though. But then okay. I think that's it. So yeah. So let's take the next law. The next law has to do with division, right? So the first law says when two same bases are multiplying, you add the powers. And we saw a to the power n multiplying a to the power m, and then we had a to the power the sum, which was what? M plus n. Good. The second law says when two same bases are dividing, you subtract their index. You understand? When two same bases are dividing, subtract their index. So, or powers, that's what I mean. So when dividing indices with the same base, subtract the powers. So see this, a, same base, a, and you have m, and what changed? The sign. So with multiplication, we add the powers. Or division, we subtract the powers. Understand? Good. So let's take an example. So for example, you have something like 3 to the power 4 divided by, let's say, 3 to the power 2. What do? is a law. It's two same bases. You write the base and then you subtract their powers. So what do you get? 3 squared. Simple as that. You understand? So let's try to see what examples do we have. Okay, so my examples, let me see if I have friendly examples. Good. So my first example for this law is p to the power 7 divided by p to the power 3. Let's solve it. So when two same bases are dividing, from the second law you subtract their index. 7 minus 3. So when you're solving, you can tell them, you can write the law down that from the second law of indices, then you start. So p7 minus 3 is what? 4. You understand? Good. Let's see another example. Good. Let's see this one. My second example here would be look a little bit complex, but then it's not. 21a exponent 9, right, divided by 7a squared. So the numbers would affect themselves, and then the alphabet will also affect themselves. So you can write this as what? 21a exponent 9 over 7a squared. 7 goes into 21 3 times completely. Understand? And then this becomes 3, right, to brackets a to the power 9 over a squared, right? So from the second law, what do? You subtract the index. So write the base and subtract the index. So what do you get? 3 to the power 7. Good. Let's take another example and then we'll go to a complex one. Yeah, so let's take this one. 42, very sorry for that. 42 a to the power negative 3, right, divided by 6 a to the power negative 8. So let's rewrite it. 42 a to the power negative 3 over 6 a to the power negative 8. So the numbers cancel and then the alphabets will deal with themselves. So how many times would 6 go into 42? So for those who don't know this of head, I'll make another section on what we call divisibility rules, where I'll teach you what numbers can divide what by just seeing them with your eyes. But then for now, let's recite our 6 times table. I know the answer, but then of course I need to help us. So 6 1 is 6, 6 2 is 12, 6 3 18, 6 4 24, 6 5 30, right? 6 6 36, 6 7 give you 42. So you see that goes into it 7 times. So it means you get what? 7. And then you write your base. And then, according to the law, you subtract. So you subtract the negative number. You see, when two same bases are dividing, you subtract their index. So we have what? 7a. You know the nigga po, right? So plus 8. And you know this gives you what? 7a to the power positive 5. So that's the answer. You understand? Yeah. Let me give you one that's a little bit complex. So this is my example 3. And then to my example 4. So simplify, right? Simplify. 12x to the power 5, right? Y to the power 7, right, divided by 3x squared y. So you can pause it and simplify it on your own and then compare your answers to what I would get after, right? But then let's do it. Okay, so sorry for that. Let's do it. So all the numbers are one place, and then you group all the things with x at another place. So you group them at another place. You see they are multiplying, so you are separating them by the multiplication sign. You understand? And then the division goes. So that's how you have to write all this. Understand? So that you'll be able to visualize it very well, and then be able to deal with the signs. So group like terms, numbers here, all our x here, and all our y here. Right. So let me divide the space adequately so that we move on. So how many times will 3 go into 12? Let's recite our 3 times table. 3, 1, 3, 3, 2, 6, 3, 3, 9, 3, 4, 12. So you need to go in 4 times. So you write your 4, right? Then x to the power 5. So you write your x down. When two same bases are dividing, what do you do to the powers? You subtract their index. And then you come and write your y. When two same bases are dividing, you subtract. So you know writing y alone is the same as writing y to the power 1, right? So you come and write 7 minus 1. So this implies that you get 4. 5 minus 2 is what? 3. And y, 7 minus 1 is what? 6. So this is our final answer. Do you understand it? Yes. So for multiplication 2, you group all the numbers at one place, or the h's at one place, or the m's at one place. Yeah. Right. Okay, so let's go on. So let's go on to the next law, which is the third law. So the third law says to raise a power to a power, when one of the powers is in the bracket, you would multiply their index. So when there's a power outside the bracket, right, multiply the power. Simply, to raise a power to a power, you do what? You multiply their index. That's all. So you have something like this: a m brackets raised to the power n, multiply their index. So write the base and then multiply their index, m n. You understand? So assume you have something like 3 exponent 2, and you want to raise this whole thing to an exponent of, let's say, 3, right? So I want to cube this expression, 3 squared. The law says to raise a power to a power, you multiply their index. So 2 times 3 is what? 6. That's it. So let's take some examples. So our first example, as usual, okay, you have a, right, cubed this, this expression. Oh Jesus Christ, I don't know if I'm still Gen Z though, because I don't know what this phone is trying to do. Exponents 4. So from the law, we said what? To raise a power to a power, you multiply their index. You write the base 3 by 4. That should give you what? 3, 4, 12. Understand? So let me give you another one which you can do. I'm still thinking of a question to give you to raise a power to a power. Good. So 2. So the reason why this is like this is because, okay, let's do this one and then we'll do. So 10, right, a cubed, right, all this squared. So let's solve it. Now for a problem like this, you have a number and an alphabet. This power affects the number, and then this power affects the alphabet, and then the law applies. So you have something like this: 10 squared, right, times a cubed, this expression squared. So this is what you write. You understand? Because the 2 affects the 2 of them. So what is 10 squared? It's what? 10 times 10. Some of you might have written 100 already. I know you lads are smart out there. And then when two same bases to raise a power to a power, you multiply their index. So 3 by 2. So that means you have what? 10, 10, 100. Good. Times 3, 2 is what? 6. So a to the power 6. And you have what? 100 a to the power 6. So that's how you go with these problems. So let me give you another one, which I think is quite a brain teaser. Take this one. So you have something like negative. So that's my third example. Negative 4 multiplying a to the power negative 3, right? I really don't know how to clean, so let me cancel it and rewrite it well, so people who have visual issues would not have a misconception of what I'm saying. So negative 4 multiplying a raised to the power negative 3, right? Or this whole expression, oh Jesus Christ, what's happening to this one? This whole expression squared. Good. So what do we have? So I told you there's 2, right? You can solve it on your own, but then we can do it. So you see this 2 affects the number, and then it affects this as well, the alphabet. So what do we say? Negative 4 in brackets we square times a to the negative 3 squared, because the 2 is affecting the 2 variables, you understand? So what is negative 4 squared? You can write it as negative 4 times negative 4. Now when you come here, raise a power to a power, you multiply their index. So what do you have? Nege, po. So you know you have positive. 4, 4, 16. Nege, po, nege. Right. And you know you have to write your A down. 3 to 6. So you have positive 16a to the power negative 6. As simple as that. Right. In the next law, right, would see, one of the next laws would see how you can rewrite this expression. You understand? So let's go on. Let me give you another example. Let's see how it goes. Do I have another example? Yes, I do. Let me give you another example. So we have something like this. Example 4. 5x raised to the power negative 3. So you can pause it here and solve. When we are done, you bring your answer out. You can pause it and solve. When we are done, you bring your answer out. So let's do it. Well done for solving and pausing. If you didn't pause too, Charlie, I see you. So the negative 3 affects your 5. Negative 3 affects your x. So you write what? 5 exponent negative 3, right? Times x exponent negative 3. I told you this means 1, right? So we'll be talking about it. So 5 exponent negative 3 times what? X. So to raise a power to a power, you multiply their index. 1 times negative 3. Negative 3. Poor niggy. You understand? So you know the x is also carrying a negative. And then 1, 3 is 3. Right? You can write it like this. Now the next law, we'll learn how to rewrite these. So keep these answers in your head. 16a to the power negative 6 and 5 to the power negative 3, x to the power negative 3. Excuse me. Okay, so the next law, right, is the law which has the power of 0. So listen to the law. Any non-zero value, I repeat, non-zero, is the power of 0 is equal to 1. So a equals 0, a to the power 0 is equal to 1. And this is only true if and only if. That's how I write it. So if and only if, right, a is not equal to 0. So any non-zero value. So far as the a is not equal to 0, when you raise it to the power 0, you get what? You understand? Good. So let's do some examples. So you have 3 to the power 0 equals 1, 2 to the power 0 equals 1, 1 to the power 0 equals 1, 6 to the power 0 equals 1, 1 billion. 1 million. 1 million 1 0 0 0 0 to the power 0. Still 1. Any non-zero value raised to the power of 0 is equal to 1. So let's do some examples. Good. What examples do I have for you? So of course, our usual. So a to the power 0 is equal to what? 1. The second part, what other power 0 do I have? Good. So I have something like this: 12a to the power 0. Good. So this means that you are having 12 multiplying the expression a raised to the power 0. And any non-zero from the fourth law, any non-zero number raised to the power 0 is 1. So automatically you know the answer here is 1. So you have what? 12. Good. Right. Let's go to our third example. Assuming you have 12a to the power 0. Right. Good. Where a is not equal to 0, or where a is a non-zero number. So what does this mean? Where a is not equal to 0. This is the question. Simplify. Right. So solution. Now solution, we see from the fourth law of indices, right? This you can write it as, so the 0 is affecting the two of them. You understand? Because this time it's outside the brackets. You understand? So 12 raised to the power 0, right, times a raised to the power 0. So you can use the fourth law or the third law. In the fourth law, we said any non-zero raised to the power 0 is equal to what? 1. So here you get 1 times 1. And that will give you what? 1. Right. Or when you are using the third law, so this from the fourth law, when you are using the third law, right, you see 12 to the power 0 times a to the power 0. You still end up coming to use the fourth law, so don't worry. Let's go. So third law, to raise a power to a power, you multiply their index. So what do you have? 12, 1 times 0 times, right, a, here is 1, so 1 times 0. So what do you have? This at the top. So what do you have? 12 to the power 0 times a to the power 0. From the fourth law, any non-zero number raised to the power 0 is equal to what? 1. So 1 times 1, which will still give us 1. Do you get the understanding? Okay. So let's go to my fourth example. My fourth example, you have something like this: 32x, right? This whole expression raised to the power of 0, right, times 6 squared. This is my example 4. Example 4, right? So what do you have? So from what we've done so far, any non-zero number, base raised to the power 0 is 1. So this whole bracket raised to the power 0 is 1 times 6 squared, right? So 6 squared is what? 6 times 6, and 6 times 6 is 36. I don't know if you know that in Nigeria, if they still teach it. So that's it. That's how to do it. Let's move on to the next law. So the next law, law 5, is what? Negative indices. Negative indices. So simply put, when you have any base raised to the power of a negative index, just do 1 over that expression, but this time change the negative to positive. So see something, a to the power negative m. So you write 1 over, then you write this term, but then you take the negative out. So let's do 3 exponents negative 2. What do you have? 1 over this expression without the negative, so this one becomes positive. So 3 exponents positive 2. You understand? If you have 5 exponents negative 10, what do you have? You come and write 1 over 5, and then this one becomes positive. So let's go back to those answers we were writing, and let's see if we can convert them to a form like this. So we had 16a to the power negative 6. Let's bring it here. So you have something like 16a to the power negative 6. And then the other one was what? What was the other one? The other one was 5 negative 3x negative 3. So 5 negative 3x negative 3. Good. So these will be some of our examples will be using. So this can be written. So let's come here. So our first example is that one. 16a to the power negative 6. So this can be written as 16 times a raised to the power negative 6. What does this mean? From the fifth law, right? 16 times, so flip this one, 1 over, and then this one becomes positive, a to the power 6. 16 times 1 is what? 16. So 16 over e to the power 6. And that is the answer. Let's take the second example. 5 to the power negative 3, x to the power negative 3. So same thing applies to them. 5 to the power negative 3 times x to the power negative 3. Right. So, guys, excuse me. Let me pick this call. Good. So what do we have? So you write it 1, and then you flip it, and then it becomes positive. Times you write another 1, flip the x, and then here becomes positive. So I told you, if you have a to the power negative b, just write 1, flip it, and then it becomes positive. So that's what I've done here. Okay, good. Now, what is 5 cubed, or 5 times 5 times 5? So this is the same as 1 over 5 times 5 times 5 times 1 over x cubed. 5 times 5 is 25, times 5 is 125. So you have 1 over 125 x cubed. And this is our final answer. Do you understand? Okay, so let me see if I'll find another. Okay, so we have another 2a to the power negative 3. So what do you do? 2 times a to the power negative 3. Your 2 stays, times 1. So you flip a cubed. You end up getting what? 2 over a cubed. And that's your answer. Okay, so let's move on to the next. Alright, good. We'll be done in a bit. I don't want this to take so long, so you don't have to sit behind it for a very long time. This is a bit advanced for GHS level, but then I'm teaching indices and that's a set law, so I have to teach it. So if you have anything in this form, right? So x a over b, right? This is the same as b root, the bth root of x raised to the power a. So for example, if you have something like 2 raised to the power, let's say 1 over 2, right? This is the same as the bth root. You see the bth root, so just put it there. 2, square root, not 2 multiplying root of what's x, so 2, and then this one comes up, so 1. Now in mathematics, square root is not written like this, so you end up writing square root of 2. You understand? So anything raised to the power half is square root. So what they are trying to say is anything raised to the power of something is the root of that thing. So let's say 2 raised to the power 1 over 3. It simply means cube root of 2. Understand? Cube root. 2 raised to the power 1 over 4 is the 4th root of 2, because the 1 will be here. Understand? So it's not meant for GHS level as far as I'm concerned, so I'm not forced to teach it, but then let me solve a few examples with you so you would know how to go about it. So let's take an example like 27 raised to the power 2 on 3. So what do you have? 27, right? So we said if you have x to the power, so for this I would advise you to write the rule. So x to the power a over b is equal to what? The bth root of x, or this expression exponent a. So where is b? B is 3. So 27 2 on 3 equals the cube root, right, of what? 27, right? Then the 2 comes up, this expression squared. Cube root of 27 means what number will multiply itself 3 times to give you 27? So cube root of 27 is 3, right? Because 3 times 3 times 3, 3 is 9, 9 3 is 27. Understand? So the answer is 3 in the bracket is squared. What is 3 squared? 3 times 3, and I'll give you 9. That's it. So because it's not your level, I don't really want to stress much on it, right? I don't really want to stress much on it. So let's move on. So we have some practice questions here. We've got some practice questions here, and I'll be guiding you through them little by little. So let's have fun. You can solve it all before we move on, right? I advise you to do that. So as you are doing it, you'll be following and finding out your mistakes. Yes, and the videos, don't just watch them once. You can just watch them over and over and over. I'm speaking very slowly so that you'll be able to get it. But once you get a hang of it, you can play my video in times 2 so that you'll be able to revise faster. Right? Okay, so let's move on. Good. So how do you solve this? You have been asked to simplify. So simplify. That's the preamble for all the questions. Simplify. Good. So I've shown you how to do this. So write 4a to the 6 times 5a to the power negative 2. This means 4 times a to the power 6 times 5 times a to the power negative 2. Group the numbers at one place. So 4 times 5 is what? 20 times. What law are you using here? What law? What law? You see, what law says that when two same bases are multiplying, what you add their index? If you forget, see multiplication, it looks like what? Addition. So when two same bases are multiplying, you add their exponent. You understand? When two same bases are dividing, see division, looks like subtraction. You subtract their index. You understand? To raise a power to a power, you multiply their index, right? And then when you have any non-zero number raised to the power 0, the answer is what? 1. And then when you have that expression x to the power a over b, the answer is what? The bth root of x, all raised to the power e. Good. So here is the first law. So when two same bases are multiplying, you add their index. So 6 plus negative 2. So this means you have 20 multiplying a power neg is neg. So 20 a to the power 4. And this is your answer. Do you understand? Good. If you have any questions, you can drop them in the comment section. I'll be glad to address them for you. Alright, so another wonderful one. So simplify. So what's the solution? So negative 3 a to the power 4b times 6a to the power 7b. So let's group all the numbers at one place. Right. So this implies negative 3, negative 4 is negative 3, 6, 18 times a. When two same bases are multiplying, you add their index. So b and b can be added, so we add. So negative 18 a to the power 4b plus 7b, so it's 11b, and that is our final answer. Alright, okay, so we move on to the next. So write our solution nicely. Oh, I'm having terrible neck pains. So right is 20b to the power 10 divided by 4b to the power 5. So what do you have? The numbers at one place and the alphabet at one place. 20 over 4 times b to the power 10 over b to the power 5. What is 20 over 4? 5 times, because 4 1 4, 4 2 8, 4 3 12, 4 4 16, 4 5 20. So that's the 5 times b to the power. When two same bases are divided, you do what? You subtract their index. So 10 minus 5. Let's go with 5b to the power 5. That is your final answer. On to the next. Okay. So we have 42 a to the power negative 3 divided by 6 a to the power negative 8. We group our numbers at one place, then we group our alphabet at one place as well, separated by our multiplication sign. 6 times 4 to give you 42. Let's see our 6 times table. 6 1 6, 6 2 12, 6 3 18, 6 4 24, 6 5 30, 6 6 36, 6 7 42. So 7 times. Two same bases are dividing, you subtract their index. Negate poor. Negative 3 plus 8 is 5. I think we've done this already. Yes, but I brought it again so that you know that I can bring it again. Alright, so that's how to solve it. The next. So you have your 32x raised to the power 0 times 6 squared. You know any non-zero number, right, raised to the power 0 is 1. So from the fourth law, this becomes 1 times 6 times 6. And this becomes 6 6 36. And we are gone. Okay. This 5x all raised to the power 3. So I told you that 3 would do what? Would affect this and this. So 5 will become raised to the power 3 times x, which is also raised to the power 3. 5 raised to the power 3, so it's 5 times 5 times 5, which is 125 times x cubed. 125 x cubed. Good. Now we've come to some of them. They look plenty, but then they are easy. Right, just go according to the things I've been telling you, you'll be fine. So you have something like this: 6 times h cubed times m to the power 6 times 4 times h to the power 4. Let me stabilize my screen. Times m to the power 5. So group all the numbers at one place. 6 times 4. Group all the h at one place. H to the power 3, or h cubed, times h to the power 4. And group all the m's at one place. m to the power 6 times m to the power 5. 6 times 4 is what? 24 times when two same bases are multiplied. You see h and h, you can't do h and m because they are not the same. You can do h and h, you can do m and m, the toffee, but you can't do h or is the wrapper. M and m is the wrapper. Yeah, you can do h, yeah, it's also the toffee. You can do h and h, but not h and m. You can't do h and m when two same. You see, I've been saying the law, when two same bases same. So you add their index 3 plus 4, you see, times same basis. So add their index 6 plus 5. So you get what? 24 h to the power 7 m to the power 11. Even if it is m times, so this is the final answer, but I'm just saying, if it is m times 6 times m times 7 times m times 8, right, times h, right, h is not the same as this, so write your h, and then the same bases are multiplying. So you do what? You add their index. 6 plus 7 plus 8 is what? 21. So h exponent 21. You understand? Good. So let's move on to the next example, and then I think this will be one of the last, and then we are done. Very sorry this lesson took a long time. 12x to the power 5y exponent 7 divided by 3x squared y. Good. I think we've done this already, but then we need to go through a little so you understand more. So you group your numbers at one place and your x's at one place, not your ex-girlfriends, guys, your x's, and your y's at one place. Good. 12 on 3, I mean, it will be 4 times. Then the law, second law, when two same bases are dividing, you subtract their index. If you don't, even if you don't remember the place where the law is, just remember the law that when two same bases are divided, subtract the index. And I told you this is the same as y to the power 1, so we subtract 1. Okay, so you get 4x cubed y to the 6, and that is your final answer. Alright, I'm trying to swipe. Good. So we come to the end of our lesson much too soon. So what I would like to leave with you, a little joke. What would you, who have watched my video and participated and dirtied your hand in mathematics today, have in common with this guy the next time you meet math or indices? What do you think you would have in common? So I think you guys will just say it's not a big problem for you. What's next? Thank you for tuning in to STEMbridge. This is our first video. You can put in the comment section what videos you want me to do next, science or math, and what topic, and then we'll move on from there. Have a nice and lovely day wherever you are all around the world. Thank you.